Good morning, everybody. I'd like to welcome you to the Advanced Propulsion Centre and the Low Carbon Vehicle Partnership's third Automotive LCA webinar, Energising a Sustainable Future. My name is Gloria Esposito. I'm Head of Projects at the Low Carbon Vehicle Partnership. Today we'll be looking at the role of low carbon fuels in decarbonising transport and some of the sustainability issues related to sustainable supply chains. I'm joined today by a range of wonderful expert speakers, and they are Dr. Kylie Whitaker, Penny Atkins, Ben Madden and Chris Mallins. I'd now like to pass you over to my co-presenter, Philippa from the APC.
Morning everyone, great to have you all here. Hopefully some of you have managed to attend the previous sessions. So just from me to start, a little bit of housekeeping. So if I just share my slides. So please feel free to pose any question and answers in the Q&A box at the bottom of your screen. If you have this specifically directed to one of the panelists or one of the speakers, then please let us know which one. We'll try and get you to ask those live. So one of the team behind the scene will come to you and see if you're happy to ask those. We encourage you to use the chat function to speak to your fellow attendees or to ask us if there's any other discussions that you might want to start raising. We encourage that networking in the chat function. We will be recording the sessions today, so those will be available after this. So if there's particular presentation or slide that you want to look at in more detail, you'll be able to access that after today. We encourage you to be social. We're using a number of the social media channels, using the hashtag LCA Week. So again, this will enable you to contact either the Low CVP or the APC around this topic, or to speak to other attendees. So to keep the discussion going, we're really keen on doing that. And then finally, towards the end of the session, and as we finish the webinar, there'll be a short SurveyMonkey questionnaire. It'll only take you a couple of minutes to give us feedback and help provide us with insight for future events. Right, back to Gloria.
All right, thank you, Philippa. I'd like to now introduce our keynote speaker, Dr. Kylie Whitaker. She's a Principal Sustainability and Compliance Specialist at the Department of Transport Low Carbon Fuels team. Kylie, over to you.
Right, so thanks so much for joining me today. I'm just going to reset my timer and just to keep to time because we've got quite a lot to cover today. So I'm very happy to be talking about in the Life Cycle Assessment Week. I've been doing Life Cycle Assessment for about for over 10 years now, and it's something that I'm quite passionate about. But I thought I'd take a step back and do a bit of sort of the context in which we're looking at transport and the challenge we have with reducing greenhouse gas emissions from transport. We're going to talk about some actual projects that we're funding in government, then take it back to the renewable transport fuel obligation, talking about what its objective is, what the strategic direction it is in the context of the transport challenge, then talk about some sort of key fuels and statistics in terms of what we actually see being used in the UK, how we regulate it, and if I get a chance, if we have enough time, to talk about the next steps as well. So, transport challenge. As you can see from this graph, it's kind of a messy graph, but one thing it's showing, a take-home message, is that lots of other sectors are kind of decarbonising quite well over the last 10, 20 years. But transport is kind of not really going at the same rate as those, and it's becoming one of the highest emitting sectors. So moving forward, looking at the next steps in terms of what to decarbonise, transport is definitely going to have a much stronger focus than it has in the past. So our sort of main challenge is this net zero target, which was announced last year. So it was previously an 80% reduction, but now it's net zero by 2050. So if we look at the carbon budgets over time, this is quite a big challenge ahead of us. And, you know, moving it down to zero, where that star is our sort of where our eyes are set. So the challenge is reducing GHG emissions, but it's also reducing the energy use as well. We don't want to ignore that at all, but in the context of what I'm talking about, it's about GHG emissions. And if we look at where the emissions from transport are coming from, a good chunk of them are cars on the road, and that's the focus of that is electrification, so where they can decarbonise the electricity sector. So when it comes to the RTFO, which has always supported renewable fuels, we see that we have to kind of focus on those areas that are more difficult to electrify. So in terms of some competitions that we're currently funding, they are trying to encourage commercial development through demonstration competitions, and these are focusing on advanced biofuels which are made from wastes and residues. And the idea is that they're going to be turning some sort of really low value, horrible, nasty things into high value, low carbon fuels, and these are the ones going into the more hard to decarbonise sectors such as aviation and the freight sector. And also by encouraging them, we can kind of boost domestic growth and building technology and things that we can then potentially export, but also creating jobs as well. And so we had two competitions. One was a while ago, and it's just coming to its close in terms of like the projects being funded. And this is 18 million towards some capital grants that are matched by industry, and a second one which is similar sort of amount of money, match funded as well, but that's not quite, there's still some projects kind of going through that. You can see where all these plants are located and the types of projects they're involved. It's quite a diverse mix. And yeah, so that's just kind of like a snapshot really of quite a big topic, which is all the projects that we're funding. And in terms of the next waves, the next competition, they're doing a feasibility study at the moment to see how that could be done and what the sort of needs are. And that will be targeted at aviation fuels, and they will be publishing the results of this study at the end of the summer. So if you're interested, you can keep an eye on that. So the objective of the RTFO, it's not a new thing. It's been around for a long time now, since 2008, and it really is like one of the main policies for reducing GHG emissions, supply and transport. The previous graph, there was a tiny dip after 2008, and most of that is due to the RTFO. So that's it really is actually having impact, even though it's still a long way to go. So the main objective is to increase the amount of renewable, sustainable fuel used in road transport. We have a sort of milestone target of 10% by 2020, but we do have targets of 2032 and beyond, so they carry on after that. So the fuel must be renewable, but it has to also meet certain minimum GHG saving criteria and land use criteria. And the fuels are assessed during a life cycle assessment methodology as set in the Renewable Energy Directive 2008. And we also report on the indirect land use change, even though we don't ask suppliers to directly report on that themselves. So how it works, so fuels, for those who are new to this and don't know how it operates, it's a legal requirement that fuel suppliers have to provide a percentage volume of their fuel as sustainable renewable fuel, and this is based on the percentage of their overall volume that they provide to the market, and this volume increases over time. And the way they meet this obligation is they generate certificates which are awarded to each litre of fuel that's actually provided. So suppliers can get these renewable transport fuel certificates, RTFCs, by either producing renewable fuels themselves, or they can just buy renewable fuels and then get the certificates for it, or they can just directly buy the RTFC certificates. So the idea is that suppliers are supporting the renewable fuel industry. They also have the option, if they don't want to support the industry, they can just buy their way out of their obligation, but obviously we don't really want them to do that. So we set a price at that, which is meant, so it's like an economic factor to kind of make sure that that is not the most attractive way of getting out of their obligation. But also it means that there's a sort of maximum price that it could get to kind of protect whoever is paying for this obligation as well. We also kind of use this certificate system to incentivise what we want to see in our fuel mix. So fuels made from products such as crops or industrial products that have other uses, these get 1 RTFC per litre, whereas fuels made from qualifying wastes and residues get rewarded double. Also fuels made from energy crops, but we don't really see so many of those because they're quite difficult to use. So as a result, we do actually see that most of the fuel mix that we get is based on waste feedstocks due to these incentives. So we know that it's doing what we want it to do. So in terms of strategic direction, so I mentioned before that the UK's long-term strategic objective is to focus on these more difficult to electrify sectors. So the future of fuels, basically, what's the future of fuels? And also we need to stimulate investment in technologies that are needed to produce them. So in 2019, we introduced a new sub-target for development fuels, and these are only can be produced from qualifying waste and residues. Also, there's another thing on the next slide, it talks about in more detail. And the way that we're incentivizing these is that they have a higher certificate price, a higher buyout price. So because these fuels will be more expensive to produce. So these development fuels are certain types of fuels and made from certain types of feedstocks. So these are aviation fuels, hydrogen, renewable synthetic natural gas, and also drop-in fuels that can be blended at a higher rate as conventional renewable transport fuels can. They have to meet a 60% GHG saving overall, and they can only be produced from sustainable waste residues of qualifying types. There's a little disclaimer at the bottom I mentioned, and they can also be produced from renewable fuels of non-biological origin, which we call FIMBOs, but some people call them electrofuels. And I think Chris Smaling will be talking about this in his presentation, so I won't go into any more detail. So there's the two things that they can be made from, and now we talk. That's why we refer to renewable transport fuels anymore, and not necessarily biofuels, because they're not necessarily all made from biological origin anymore, which is quite new in the last few years. So development fuels can't be made from segregated oils and fats. They can't be made from used cooking oil, things that are really easy to use that we need for our biodiesel. So we're really kind of trying to push the limits on what we can use and what we can get in terms of wastes. We really just want to find more wastes, basically. They can't be made from crops at all, and they can't be made from energy crops. And they also can't be made from sort of conventional biomethane generation from anaerobic digestion. It has to be, for example, that's very similar to SNG, but we don't really want, it's not really like an advanced technology that we're trying to support. So this is what it looks like over time in terms of our increasing obligation over time, starting at 8.4% with the main obligation, which is the traditional biofuels and renewable fuels that we'll see. And this development fuel target is really kind of the main driving force of the increase in targets after like 2021. That's where we start to get more of that. And that's where we get the main obligation, and we have the development fuel with the higher buyout price and the traditional buyout price. So some key fuels and statistics. These don't include development fuel statistics because they're quite new in our statistics. They're only just starting to appear. We publish reports every quarter, but we publish 6 quarters per year, which is a bit of a mind twister on that, but this is just the way that the RTFO works. And so the final report, the most recent report we've got with full data is actually 2018, and the final report for 2019 will be published in November. And so we have a sort of ready stream of these. It's just basically a plug for our stats if you want to go and have a look. I'm not going to go through all of this because we just wanted to kind of showcase that we have so much data that we try to make available, and we try to share as much as possible, and some people find these very useful as well. So if you don't really fancy going really into detail, we do also publish a sort of more it's like softer, more cute infographic report, which has got some sort of more easier to digest facts and figures, sort of providing a snapshot that you might be able to use for presentations or something, which provides all sorts of breakdowns for each report. So the RTFO unit publishes a list of approved feedstocks which will qualify for double counting. They basically have been through some sort of assessment process in terms of if they are actually genuine wastes, and if they have a sort of other use at all, and if they have that other use, is that something that we should consider if there are any sort of impacts of then double counting and using more of these in fuels, and we try to kind of do a full assessment of that. We've been seeing gradually more and more waste feedstocks coming over, which is good, is what we want to see. Trying to get rid of the not get rid of, but just completely use less crops. And we actually have a crop cap, which I haven't mentioned, but we're just moving more into the waste side. In terms of our top feedstock, used cooking oil is by far the most common feedstock we see every quarter. This dominates mainly the biodiesel supply. It's used heavily in biodiesel, whereas bioethanol is made from more of a mix of feedstocks. So we get lots of the sugary crops and sugar beet and corn, but we have a few wastes appearing for bioethanol. So we have waste starch slurry, which is just a sort of wet material that this stuff that wouldn't qualify as animal feed, used for animal feed. And also we have food waste as well, which is a waste bioethanol source. But UCO has really been like the dominant feedstock over the last few years. But as we look over time, because we've got these incentives for wastes and we're increasingly adding waste to our list, we can see that the feedstock mix is diversifying over time. And for example, in 2018, our last report shows that we made about 33 different types of feedstocks made up our renewable fuel supply, which is 1.6 billion litres of renewable fuel. In terms of our top fuels, around 10 fuels, renewable fuels, are awarded under the RTFO, but really bioethanol and biodiesel are the main ones, and that's because we blend these in with our conventional transport fuels. Bioethanol is typically blended up to 5%, though they've just done a recent consultation on whether this can be increased to 10%. And also biodiesel is blended at 7% in our current sort of up to 7% in our current mix. So these are the ones that we see in much greater sort of volumes. But I didn't want to ignore the other types of fuels because we've got some quite interesting ones there. I just thought I'd mention that biomethanol is the third most commonly supplied fuel, whereas we've got small but quite steadily growing supplies of biopropane, also of biomethane. If you look at how much has been supplied over the last few years, these are kind of actually growing quite fast. And then we also have some quite other interesting fuels such as diesel of origin bio, and also we have something called bio petrol as well, which you can see on the top of the the renewable fuel bit there. And these are where, for example, used cooking oil is put into a refinery, and the renewable content is kind of mass balanced through the refinery into the final fuel. So we get some sort of fuel that's chemically identical to petrol or diesel, but it's made from used cooking oil. And we also have a small amount, you see zero is less than is quite a small amount of methanol, which is quite interesting as well to see an actual non-biological origin fuel. In terms of where we get our fuels from, we import the vast majority of them. And in 2018, we had fuel from 76 countries. So it's a world-ranging supply chain of our fuels. This has changed over time. But at the moment, the more recent report we had, the top 5 countries were China, UK, USA, Spain, and France, and the top 5 changes quite a bit in terms of which ones. So it's quite dynamic, I'd say, in terms of what our supply chain looks like. It'd be interesting to see how this changes over time as well with COVID as well, which we'll be keeping an eye on. And in terms of our greenhouse gas savings, these are also steadily increasing over time. And in our last report, we saw the highest savings on average. So there's average savings, which is remarkable considering they started at 46% in the beginning of the RTFO. But since then, we've been ramping up the sustainability criteria and wanting to increase this as much as possible. And these are, we base these savings on a fossil fuel comparator, which is currently 83.8, but when RED 2 gets sort of implemented, we will be seeking to sort of match that that comparator in RED 2 as well. So regulation. So how do we regulate all of these different applications? I thought we'd just mention how we actually do it in the RTFO unit. in terms of, it's actually quite a hands-on approach to regulation. So for a start, any fuel supplier in the UK that provides more than 450,000 litres per period are automatically legally obliged to register an account with the RTFO unit, and we will regulate them to make sure that they are meeting their RTFO obligation. And for that, they have to redeem a certain number of certificates for the percentage of fossil fuel that they supply to the UK market. And we also have to make sure that all of those renewable fuels have met the sustainability criteria. And we provide an online platform for them to come onto this, and to also for people to come up and trade RTFCs as well. So we get about 1,000 to 2,000 consignments of fuel a month, and these cover about 300 to 400 million litres of fuel. And each of these consignments are specific fuel feedstock country combinations. We don't allow them to mix at all. We want to know exactly what it is, what country it's from, and what fuel type it is. And they must, for this, each consignment, they have to provide a carbon intensity for the fuel, and they have to meet that carbon intensity will be used to calculate if they've met their greenhouse gas savings criteria. All of the applications have to be verified by a third-party independent verifier, and many of them, 98% of them, are also audited by a voluntary scheme as well, which will basically audit their supply chain as well. And once we've got all of the volumes, people pay duty on the fuel, we will then cross-validate those volumes with fuel data, actual duty data that we get from HMRC. So when, in terms of the actual, I know that people are interested in the sort of carbon calculations, they can use default figures, which are provided in the Renewable Energy Directive. And these are obviously based on sort of typical studies, and they're aiming to be quite conservative figures. But we're getting more now. We have some incentives. We're seeing more people actually doing their own calculations. So meaning that they provide actual data, and they've actually done their own life cycle assessment of their fuel. And so when we see this as a flag, we compare what they've got against this default data, and we investigate it if it looks odd. For example, if it's like particularly low, or if there's some reason we would think we have like a risk register of why that figure might be different. And we will always investigate in more detail if they haven't used a voluntary scheme to audit there, because that means it hasn't had that audit process. We'll also look at sort of high risk combinations where there might be high risk of land use change. There's also, if there's a new country feedstock combination we've never seen before, we'll definitely try and find out a bit more about that. And we also do random checks as well, just to make sure that we're picking up things as well. And when we investigate, we ask to see the full chain of custody details. We want to see everything. We want to see like the docking information, bills of lading, landing, and also the invoices that would support that supply chain. So I've got a little bit of time, just not really that much time, just to talk about the next steps, what's happening next with the RTFO, because those that have been following us will know that we've got some planned updates. We do these regularly, legislative change and consultations. At the moment, we're talking about introducing some more types of fuels, for example, looking at recycled carbon fuels, which are fuels that are made from solid or liquid fossil wastes, which cannot be reused or recycled, or waste fossil gases, which are unavoidable, like, for example, like a steel mill waste gases. These, I think Chris will also mention these as well, so I'll leave that to Chris. In interest of time. And also we're looking at different wool types for renewable hydrogen as well. There's also looking at changes to the buyout and changes of the value of the buyout price, and also just talking about some updated criteria to be consistent with RED 2, which was published 2018. And we're also considering changes to the main obligations as well. But all of this is, we can talk about that in more detail. We've just had a quarterly stakeholder workshop with sort of the most recent updates I can share if people are really interested in these next changes. And there'll be a consultation by the end of 2020 with looking to implement the new changes in 2021. But I know there's a lot there. I hope that, if you want to come back, my email address is there if you do want to follow up on any particular points.
Great,
Thanks for
Carly.
listening. Thank you.
No, it was brilliant, really. Thank you for that. I know a few people have questioned about some of the acronyms, but so we'll make sure we have a glossary. I know you covered.
Oh, sorry.
No, it's all right. It's always the way, isn't it? I think in this field, we're always, but we can sort that out to make sure everybody's got a little
Great.
handout. When we come
Yeah,
back.
sorry. It's one of them common errors, isn't it? Rookie error.
I know. Right, okay, so now we've got time for just a few questions for Carly. So first of all, Mike Sutton.
You just kind of touched on it towards the end there about the changing of the buyout price. Do you have a feel for 30p where it will actually go to?
I think that's really hot off the press, that change to the buyout price. It's something that we announced last Thursday, I think, or the week before. Time has flown by. So yeah, I can't really comment at the moment. It's just I think we're gathering views from stakeholders at the moment of what what their views are.
Thank you. We have a second question. Hanno Bachelor, would you like to ask your question to Carly?
Yes. Hello. Can you hear me now?
I can hear you.
Great. Thanks a lot for this presentation. You mentioned about the carbon intensity, which has to be shown by the providers of the various fuels. Now, as we know, all these fuels usually need a tremendous amount of energy to be produced. Is this kind of a life cycle assessment what the providers have to demonstrate, or how is it being calculated, and how much is the life cycle impact of such a fuel compared with others?
So it's a good question, because we look at the greenhouse gas emissions rather than the energy use, but usually a lot of that energy is derived from the use of fossil fuels, of primary energy, and that has a GHG impact associated with it. So by default, a lot of the time there is a GHG cost of a highly energy intensive process, so it is captured by that. The actual calculation that is done, if you are not familiar with it, is in the Renewable Energy Directive, in one of the annexes, Annex 5, I think, or 9. Okay. Yeah. So yeah, the actual calculation is there. I happily talk you through that.
Okay. Thanks.
Thanks, Hanno. Then we've got a question from Adrian Barber.
Hi, yeah. So it's talked about these fuels being used predominantly in aviation and in heavy haulage, I would suggest, so the commercial sector, but the larger commercial sector. Is it envisaged that passenger car and light commercial will take up these fuels for the more rural areas where electrification and potentially hydrogen are not so practical?
Well, the main obligation isn't going anywhere. It's kind of, once it's reached its level from 2032, it will continue. So there will always be that blending of conventional renewable fuels in our petrol and diesel, for example, while it's there. So in terms of like super long scale, I probably couldn't say, because I think rural, there might be some sort of argument that hydrogen would kind of work in a rural location with hydrogen fuel cells, maybe. But I guess it all just depends on what timescale we're talking about. So, but yeah.
All right, thank you.
Do we have one more question? Okay, we have one last question from Federico Patinella, if I've pronounced that correctly. Federico, would you like to ask your question to Kylie?
Hi, yeah, good morning. Can you hear me?
I hear you.
Hi, I saw the food waste percentage in renewable fuels right now is currently quite small. However, that's potentially a massive resource that, in my view at least, is underutilized due to only a handful of councils really offering that as a collection. Is the Department for Transport looking to work with local councils or other parts of government to make sure that that percentage becomes higher in the future?
Well, I think the whole waste sector in general is, there are like wider government policies on waste, particularly food waste, and DEFRA kind of hosts most of that. But yeah, we don't really we kind of just provide the incentives. So it's kind of, if you build it, they will come. And we are seeing a lot more interest in food waste being used for all sorts of things. And one of the most growing sectors is obviously, that I mentioned, was like biomethane is becoming quite, and that's dominated by food waste, but that's also the renewable heat incentive as well, which is a sort of another sort of, you know, it's part of the bigger picture. The renewable heat incentive is rewarding the use of wastes for renewable heat and to decarbonise the gas grid as well. So gas is kind of an interesting one because there's lots of uses for it. So that's where I see food waste kind of mainly sitting.
Nice. Is this is it primarily commercial ventures that are providing the food waste, or the kind of the green gas along those lines?
Well, I think it's just a mix. There's a lot of I think anaerobic digestion is quite you know, localized production. But yeah, but there are some also big players as well who are looking to, you know, build supply chains and get a lot of this stuff coming in so they can upgrade it. So
thanks for your question, Federica. And Carly, thanks for a great keynote, really interesting. Thanks everyone for keeping the questions coming in as well. Hopefully we might be able to pose a few more of those to Carly later in the panel. Great, thank you.
Bye.
Thanks. Delighted to now welcome our next speaker, Dr. Penny Atkins, who is a Principal Research Fellow at the University of Brighton, and also the lead for the APC Thermal Propulsion Thermal Efficiency Spoke. Thanks, Penny.
Thanks, Philippa. Yes, so I lead the APC Spoke for Thermal Propulsion Thermal Efficiency. Actually, that means the thermal efficiency of engines and fuel cells. So as a community, we're very interested in future energy vectors and how powertrains and energy vectors might evolve in parallel in the future. So what I'm going to talk about today is some work that I've done with the community to look at potential transport future. So I'll share that with you today. I don't really need to talk about why we need to decarbonise. I'm sure you're all very aware of that, but what I thought I would share with you is some work from the Tyndall Institute at Manchester University, which I think illustrates very well the urgency of addressing greenhouse gas reduction in the near term. So this is Kevin Anderson's work that I'm sharing here, and he's looked at, if you like, a top-down assessment of what do we need to do to restrict global warming to 1.5 to 2 degrees centigrade. So in other words, how much, to an extent, how much carbon budget have we got left, and how long does that last for? So what he's done is look at the global carbon budget and then split that down among developing and developed nations like the UK to understand what UK's fair share might be. You can argue with the way he split this down, but I think that this gives a really good indication of, for developed nations, what we really need to aim at. For me, the headline is that if we split the carbon budget down like this, it gives 9 years at our current rate of carbon emissions until we are going to be looking at global warming more than 1.5 to 2 degrees C. So 2050 seems like a really long way away, but 9 years at our current emissions gives a real sense of urgency for me. And in practice, that means we need to ramp up very quickly to a reduction rate of 13% a year. And Carly's introduction gave a really good insight into how important transport is in this decarbonisation activity, because it is the biggest sector now. So it's really important that we do this and we do it quickly. I think that LCA is a really important tool in this, because we need to understand what's going to give us genuine greenhouse gas reduction. So tailpipe reductions are interesting, but we need to think across the whole vehicle life cycle. So this is some data that Low CVP have put together about a 7.5 ton truck, so a relatively difficult to electrify commercial vehicle application. And this shows the impact on total life cycle emissions of using various renewable fuels. So if we look to the very far left-hand side, we've got a conventional diesel powertrain. So the blue is vehicle production, the yellow is in use, so this is welter wheels, in other words, a combination of the tanked wheels CO2 emissions from the fuel, and then the in-use CO2 emissions, and then the tiny green line at the top is vehicle end of life, so the emissions from the disposal of the vehicle. So diesel is here, about 250,000 kilograms of CO2 over its lifetime. It's no surprise that if you substitute 20% biodiesel, this reduces, and then still further, if you have 100% biodiesel, this is from waste. So then if you look at a CNG vehicle, you can get slightly less CO2 emissions if you use fossil CNG, much less if you use food waste, and then even further reductions if you use biomethane, because there's a negative credit because you're avoiding the emissions from the manure if you generate biomethane from them. Then further on to the left-hand side, you can see we have plug-in hybrid vehicles. Let me move this so you can see the far left, which then you're using B100 to give some reduction, and then battery electric vehicles, which with fossil fuel is lower than PHEV, and then hydrogen fuel cell vehicles with renewable hydrogen. So I think what's striking about this graph is that if you compare fossil diesel with BEV, then you're getting a good reduction. But if then you think about the changing the fuel in your conventional powertrain, so 100% biodiesel or biomethane, currently with the UK grid carbon intensity, you're actually getting lower greenhouse gas emissions than you would do with a BEV right now. So it's really important to consider propulsion technology in the context of the fuel it uses. So in other words, think about LCA. So if you look at what's going on now to set what we're going to talk about in context, if we look at, and this is my calculations of transport energy use right now, so this is 2020 energy consumption. So it's mostly diesel used in passenger car, truck and marine. It's followed by kerosene and petrol and HFO. And if we look at what percentage of renewable fuel that's actually used in those sectors, we're looking at 5% renewable fuel for road and non-road machinery. So in other words, for the diesel and petrol part of this. Electrical vehicle use is growing, so 4% share of new car sales in May 2020 is good, but the vehicle park penetration remains small. So in actual fact, it's 0.3% in 2019. So when you look at energy use at this scale, electricity doesn't feature. And sustainable fuel use in marine and aviation is lower, so 0.5% of aviation fuel is currently sustainable. So in other words, we've got a long way to go. So what we did as part of the Spoke activity, and this is working with Advanced Propulsion Centre and Low CVP as well, is we asked our communities what they viewed the future of transport. So in other words, to 2050, what do you think is going to happen in road, marine, aviation, and what do you think is going to happen to the energy vectors? So we asked this question to a very wide range of stakeholders. So the workshops were attended by people from vehicle OEMs, from the academic community, from research organisations, Innovate UK, E4Tech consultancies. So we had a really broad range of stakeholder input. So basically we asked the stakeholders two questions. What are the scenarios for net zero transport in 2050 across transport, all the transport sectors, and what are the enablers likely to be for that? So I'll talk about the scenarios for net zero transport today. So what I'm going to share quickly, so I can stay within my 10 minutes, then the high-level roadmaps that we put together for the different sectors based on the input of stakeholders. And then at the end, think about what that means for our energy mix in 2050. So this is the first roadmap, shows the marine sector. So we're looking at the period from 2020 to 2050. And as in normal kind of roadmap code, a solid bar means that it's part of mass market. The small pale green arrows means it's niche, and the darker green chevrons means that it's either introducing or fading out of the market. Obviously, anything that we're talking about at 2050 is to some extent speculative, but this is the view of our stakeholders who are very involved in research and development within the transport scene. So I feel, you know, these are the people who are working on the solutions that may well be in 2050. So a really interesting view. So for marine, currently it's all fossil fuel, so HFO, fossil diesels and some LNG. So the view of the community was that this would evolve over time to the use of more sustainable fuels, so potentially sustainable diesel and LNG, but also bringing in some new energy vectors here, thinking around potentially hydrogen and ammonia, with possibly internal combustion engines or fuel cells, depending on how those two technologies develop. Electric fuel propulsion is recognised as an option, but really only for short range journey, so hopper ferries, that kind of thing. I travelled on some of those lovely electric ferries across the Danube last year. So these things are in the market now, but really only for short journeys. So then if we look at aviation, sustainable kerosene is vital. This is the roadmap from UK Sustainable Aviation Organisation, who thought about how they might decarbonise by 2050, and it shows what's needed is a very steep ramp up in the amount of fuel that's available. Clearly, electrification may play a part in shorter journeys. It's unclear at the moment exactly how well that will progress. So the main technology that the stakeholders talked about was sustainable fuels, so sustainable kerosene. For heavy duty, also a portfolio of solutions, and I think that's a common theme that rang through the workshops, that there wasn't going to be a silver bullet technology in any of these sectors, that it's likely to be a combination of technologies, partly because there are many different vehicles and duty cycles within them. So within the truck sector, we've got short range urban vehicles where electrification is working well now. However, for longer, heavier vehicles, your 44-ton electric trucks, what the community foresaw was really a growth of sustainable fuels, so sustainable diesel and gaseous, so CNG, LNG, alongside potentially sustainable hydrogen, use in internal combustion engines possibly, or fuel cells, depending on how those evolve, and also a role for electrification, thinking about charging using catenary, so in other words, as you're moving along, so you're avoiding some of the pitfalls of very large batteries and very high energy to charge. So really a portfolio of solutions for heavy duty was recognised by the community. Off-highway shows a similar picture. I think you've got a rise of sustainable fuels, electrification, but with slightly different technologies. Rather than a catenary to power your vehicle, you might think about tethering. So in other words, an umbilical charging arrangement if the vehicle doesn't have very high physical range of movement. So for lower energy use of highway vehicles, so things like forklift trucks, electrification may work well, and hydrogen fuel cells are in use right now in forklift trucks. So a real portfolio of solutions, because off-highway is a very wide church, a very broad church, everything from forklift trucks to enormous mining vehicles. So a broad technology portfolio there. For passenger car, electrification very often does provide a good solution. Some of our stakeholders thought that sustainable hydrogen and fuel cells may provide a good solution. There was also discussion around maintaining some ICE vehicles within the park for very long range vehicles. Obviously, this depends very much on what happens around the ban on ICE. However, there was a view that electrification may not work well for very long range vehicles in the longer term. So what I've done following those workshops is to look at those scenarios that the stakeholders expressed, and also to look at some of the work that's going on out there. So looking at CCC's work, some of the work from E4Tech on marine, and the Clean Maritime Plan, to put together a scenario for 2050 energy consumption. So
1 minute, Penny.
1 minute, it's all right, I've got 2 more slides. So it's a scenario, so this is one future, if you like, and these can never be right, but this is one analysis of how the future energy vectors could look. And I think the thing that's striking here is how many more energy vectors there are. So we're looking at potentially ammonia for shipping, hydrogen coming through for trucks, maybe for shipping, maybe for passenger car. So there are more energy vectors there that we need to be thinking about. And obviously, sustainability of these energy vectors, so kerosene and ammonia and hydrogen, is really important to us reaching net zero. What I want to finish on is really a question. So what I've included here is the lovely Sankey diagram, which shows how our energy is produced and used. So it shows the complexity of the energy use infrastructure. So transport is this blue piece that comes along here, which is relatively straightforward right now. It's fossil fuel use. But obviously, if we're thinking about using other vectors like electricity and hydrogen, then we're going to be competing for those energy sources with industry, power generation and domestic sources. So I think I'd like to end on a question around how do we build supply volumes so we can decarbonise sufficiently, but then prioritise the use between those sectors. And perhaps leave with a thought from a transport point of view is that for mobile applications, energy density is really key. Obviously, commercial requirements, market acceptance, safety, air quality, there are many, many factors that influence how suitable energy vectors is, but energy density is really important. So we think about electric vehicles in this context. This is my e-bike that I commute on. I travel about 10 miles on it. It's fabulous, works really well, gives me all the range I need. Passenger car, yes, those can work well as long as we've got good charging infrastructure. But if we think about a ship that with lithium-ion batteries, with the sort of energy densities that we envisage, it leads to a very large battery at a very, very high cost. So I think we need to think very carefully about how we prioritise energy vectors between sectors. So we're doing some more work. In the autumn, we'll be thinking about what the cross-sector R&D needs might be to deliver those kind of technologies. So if you'd like to get involved, you can come and see us on this link or just drop me an email. So thank you very much. Thanks for listening.
Thank you very much, Penny. That's very interesting to see the complex challenge that we have to deal with in the transport and energy nexus. Thank you. I'd now like to introduce Dr. Chris Mullins, owner and consultant at Zoology, that's going to talk about some of the sustainability issues regarding sustainable supply chains. Thank you, Chris.
Hi, thanks, Gloria. Hopefully you are all hearing me okay. It is a pleasure to be, well, in the same place as I always am, of course, but pleasure to be with you virtually. I guess for those of you who aren't familiar with the renewable transport fuel obligation or don't think that much about transportation decarbonisation strategy, some of what we've just heard may have seemed a little complicated. Let me assure you, it is much more complicated than that. And I have been invited to take the next, well, 9.5 minutes now, to do really a very quick tour of some of the challenges that are involved in sourcing, regulating feedstock for the fuels or the alternative fuels that we've talked about. So, basically we have a few different categories. Carly alluded to most of them. You see a lot of these already cropping up, no pun intended, in the transport statistics that DFT publish. But the history of alternative fuels to date has largely been about farmed food crops, certainly at the global level. Within the UK, the last 12 years have been characterised by a lot of use of waste materials, in particular used cooking oil. But at the broader scale, we're still talking about farming corn, farming sugarcane, farming palm oil, soybean oil, these sorts of things. For some time, there has been a general agreement that it would be good to move on to what we call an advanced biofuel, or sometimes a second generation biofuel. And that means farming biomass. So the characteristic of first generation is that we have high energy molecules being produced by the plant, starches, sugars, and oils. And we can take advantage of that. It makes the chemistry simpler to produce a transport fuel. You can go down the complexity chain, start looking at woody material, grassy material, cellulose and lignocellulose, if you've heard of those terms. And that means you have to do some more complicated chemistry to produce a fuel. But in principle, you may be able to get a greater yield, so more material per hectare of land. You can avoid food markets, which has, as many of you will be aware, been controversial. And potentially you can go to lower value land that is less suitable for food production and such. You can start moving down the chain into byproducts. So some of the secondary materials that are produced in the agricultural supply chain, but probably are already being used for something. That raises new questions. You can go to residues that have relatively limited use at the moment. That has a different character in terms of sustainability assessment. You can get down to material which is waste in the most literal sense, which is to say material that is disposed of without any value or utilization. Someone raised this in the questions earlier. You can start thinking not only about biomass wastes, but looking at fossil wastes. That is waste materials that were derived from oil resources, for instance. So waste plastics, some of those industrial gases which carry energy inherited from fossil fuels. That raises new issues. And there really is a long list of questions that you can assess when it comes to considering any of these fuels, but some of the most important are for the food crops and for anything that is taken away from the market and might be replaced with a crop. You're looking at land requirement, you're looking at the impact on other markets. Are you making food more expensive? Are you preventing existing value chains from operating? We've talked about life cycle analysis. I'm going to talk about that a little bit more. There are methodological choices. If you make different methodological choices, you will get different answers. One thing I'm going to hark back on is that there is not generally a single correct answer to a life cycle analysis question. And these assessments all have uncertainty and variability. The use of default values can mask the fact that really you can have quite different performance even for similar supply chains. And I've got plenty to talk about with the climate, but with these systems, we also have non-climate sustainability concerns. Is there an impact on biodiversity? What's the water use? Are there waste disposal, air pollution questions, etc., etc. So this is a complex system, and you can go back the last 20 years in particular, and especially the last 12, find really a lot of literature that goes over this. If you're looking at these first generation biofuels, most of the ethanol that we're using in the UK and certainly more globally, most of the biodiesel that's used, we're talking about material that comes from the same production systems as food or perhaps as animal feed. And therefore, I think it's fairly obvious to most people. This has been a controversial point at stages, but it's generally accepted. This does compete potentially with food production. Modern farming also exerts a generally high environmental burden. That's something that has to be considered. And when the farmed area expands, you tend to lose carbon from biomass and from soils. And it is perhaps easier than you would think to lose enough biomass from carbon and soils without going into the sort of the densest forests to eliminate a lot of the benefit of using an alternative fuel. So these questions, indirect land use change, food versus fuel, have taken a lot of energy in the analytical community over the last 12 years. Going to these second generation fuels suggests the possibility to maybe move around some of these. You have cropping systems that support more carbon sequestration. So, and that's positive in itself. It increases potentially the number of types of land where you can deliver a net benefit. Often, but not always, these systems may require lower input intensity. So maybe less fertilizers, less water use, pesticide, etc. But we're still talking about something that could compete with food systems. And if you look at the very high deployment scenarios for biofuels, you are really talking about an enormous land commitment. I can't overstate that. you would need really a very large amount of productive land to achieve transport energy delivery on the scale of total consumption. One way to avoid some of the sustainability problems and often to deliver a better life cycle analysis outcome, lower carbon emissions outcome, is to move to byproducts, residues and wastes. It's important to understand a lot of materials that are byproducts that some people would think about as residues are already used, inputs for chemical industries. There's an awful lot of material that is fed to animals and would need to be replaced with something if that were taken away. And sometimes there are materials which are quite systematically already used for energy reclamation. For instance, the pulp and paper industry produces a lot of residual materials that have energy reclaimed. So you get to policy questions like, is it useful, is it valuable for the government to go in and take action to move these resources away from the pulp and paper industry itself and into the transport sector? You know, it's not always obvious that that is worthwhile. And as you take materials away from an existing use, you can have issues of indirect emissions, not necessarily at the land use change level, but you know, at the very simple level, if you take boiler fuel away and that's replaced with fuel oil, there's a carbon emission associated with that. Getting away from biomass resources, as I said, plastic to fuel was mentioned earlier. In the Renewable Energy Directive recast that came into European law in 2020, which I believe the UK still intends to take a lead from for UK policy for the time being, this category taking residual fossil energy remaining in material produced from oil or from coal resources, less so. There are questions here like a very simple one. If you're taking material that would have gone to landfill, it's not necessarily environmentally friendly to landfill plastic, but the carbon in that plastic is going to be sequestered pretty much indefinitely from a sort of human time scale. So you have real questions. Is there a net carbon dioxide emission reduction delivered by reducing landfilling to increase fuel use? So some of these may be a waste management technology more than a climate mitigation technology. And again, you get into the question of replacing existing energy recovery systems. Is transport use better than incineration with energy recovery? We also have these refombos, electrofuels, e-fuels, taking electricity to produce hydrogen, using the hydrogen as a basis, well, either in its own right or as a basis to synthesize hydrocarbon fuels. The real challenge with this is that it's not actually so simple as you might expect to identify what it means for electricity to be renewable. It would be simple to do a sort of a paper exercise where we label the electricity for these facilities as renewable because of some basic relationship with the wind farm or a solar farm, but we could end up creating a regulation that just ring fences renewable electricity for transport fuel production without bringing new capacity to the system. And you might find that that not only didn't deliver emissions reductions, but actually, because these electrofuel systems have quite a few inefficiencies, that they have a much lower system efficiency than electricity use in a battery, you could find that you're making the climate impact worse rather than better. In all of this, you need to think about life cycle analysis methodology. Setting a regulatory life cycle analysis framework requires balancing complexity. You know, businesses want things to be simpler, ideally, which is understandable, and, you know, up to a point is correct. We have a drive for consistency. You can have challenges in data availability. And you have to try to balance all of that while producing a result which is actually relevant to the question being assessed. And certainly in the past, with issues like having a convention where you ignore land use change or indirect land use change emissions associated with first generation biofuels.
1 minute left, Chris.
We have had systems that don't necessarily give a good characterization of the actual net emissions impact of the technologies we're using. And as I said, different LCA methodologies are appropriate to answer different questions. It is not the same to ask how much energy was associated with producing a material as what is the impact on net emissions of starting to produce that material. To recap that real very brief tour, We know that alternative fuel production systems are not created equal, and we have a growing portfolio of options on the table, but it should be understood that the life cycle analysis results that you see quoted don't necessarily paint a whole picture, and there is a lot more complexity to get into for those of us who have the time. And in particular, these indirect effects or displacement effects can dominate net emissions over and above the energy inputs that actually go directly into producing something. This can be difficult to regulate. You know, I think the European Commission is trying its best, as is, of course, the UK Department for Transport, and these things will evolve. And you then get interaction between different policies, which is also challenging to manage. I've run over even a little more than I thought I would, so I'll stop. Do feel free to email me offline if your question doesn't get through in the session. Thank you.
Thanks, Chris. Don't worry. Really interesting presentation there, thanks, and really clear about some of the assumptions and challenges that we need to really consider when looking at those boundary conditions. So delighted to move on swiftly to our next and final panellist, Ben Madden, who is a director at Element Energy.
Okay, brilliant. Well, thanks very much for having me. Yeah, just brief introduction. My day job is as a director at Element Energy. We're a low carbon energy consultancy. We work across all of these different energy technologies which are going to be required to get us to net zero carbon. But I head up our hydrogen team, and we've got about 20 people working on hydrogen at any given time. But today I'm kind of wearing two hats, because I also provide the secretariat to the UK H2 Mobility Group, which is a group of industrialists looking to promote or accelerate the use of hydrogen for mobility in the UK. And what I want to talk about today is just give you a bit of a flavour for developments in the hydrogen sector, and perhaps illustrate how those developments are butting up against some of these LCA challenges that Chris mentioned in the previous talk, with specific reference to hydrogen. So today's an auspicious day for hydrogen. The EU will launch a 140 billion euro hydrogen strategy out to 2030. Accidentally making a noise. So that means that the EU has decided to effectively, that the hydrogen technology has moved now from the point where it's a maybe to recognizing that it's something that's going to be required if we're going to achieve net zero carbon, and has been prepared to put considerable sums behind it. We've seen similar moves from a number of the member states like Germany, Portugal, and other member states in Europe and around the world. So a kind of a decision has been made internationally that hydrogen is going to play a role in our energy system for a range of applications, some of which are industrial, some of which are heat, and certainly the aspiration from the strategy proponents is heavy duty transport, at least within the transport sector. And then we're seeing moves from industry to follow suit. So I like the picture in the top right is of a fleet of 10 hydrogen trucks making their way to Switzerland. They're the first trucks in a 1,600 truck rollout program. And you may have heard the noise emanating from a number of the UK bus manufacturers, that one's from Wrightbus, about trying to promote a strategy to accelerate use of hydrogen in buses. So hydrogen's really starting to move, and one of the reasons is that the fuel can be generated from a wide range of low carbon fuels. I guess the one that everyone talks about is electrolysis. I distinguish between electrolysis, where you put your electrolyzer near a wind farm and then move the hydrogen to the point of use, or electrolysis where you put your electrolyzer near where you want your hydrogen and you distribute the power via the grid. In both cases, provided your electricity is renewable and meets the various criteria that Chris discussed, then you have a renewable fuel. You can also make it from biomass, and often the gasification-based chains end up most efficient if you end up with a hydrogen end use. Or we can make it from our fossil hydrocarbons, as long as we bury the carbon and safely store it underground. There's also, and this is a particular challenge for LCA people, the possibility of using spare hydrogen that's made from existing processes. And then there are new options in the lab, photochemical, nuclear heat, etc., all of which promise very low carbon. And I guess the exciting thing from a hydrogen industry guy perspective is that it now looks like both the renewable electrolyzer option and the CCS option have the potential to deliver an affordable fuel, I would contend a very low carbon fuel at scale. So we're now starting to see that's really what's driving the strategic push for the technology. The problem that we're finding, and I guess the reason why I'm here and recognizing the need to engage with the broader LCA community, is that not everyone has sort of recognized this momentum This graph is really the one that actually triggered our desire to sort of get slightly more involved in LCA. I won't go through the details, but fundamentally it summarizes the low CVP's view of the current status of the different fuels as per an analysis that was done a few months ago, into which we had quite a lot of input. And basically what you can see is the only hydrogen pathways are the 4 on the right, and they all look like a much higher carbon intensity route than pretty much all of the other fuel types. And so there's a mismatch. On the one hand, you have a number of people making very bold claims about the low carbon intensity of hydrogen. And then on the other hand, when you look at today's options, and this isn't an incorrect analysis, it just focuses on today's way of making hydrogen, you see a much higher CO2 footprint. And you can imagine from a policymaker perspective, if you stand to be spending very much time promoting hydrogen technology. And that's frustrating, I guess, to those that are in the hydrogen sector, because what we can see is that if there's any kind of success for hydrogen in the transport sector, we're going to need new plant. There basically isn't enough hydrogen production capacity to do anything other than a token amount of hydrogen for new transport applications. And industry is starting to respond to that. These are just some snapshots of recent announcements of projects which are in various stages of development, all of which are trying to deploy electrolyzers at more than 100 megawatt scale. So we see Shell with a 200 megawatt and a gigawatt plan in place for the Netherlands. We see something similar from BP, Uniper, offshore wind projects being considered. And in fact, just last night, a 2.2 gigawatt project was announced in the Middle East to ship renewable hydrogen around the world. And the key point about these projects is that they couple renewable energy and electrolyzers. So the electrolyzer is actually part of the development program for the renewable energy deployment. And we see something similar in the UK. On the right is a project that Ørsted are working on with ITM Power and the refinery Phillips 66 to explicitly couple an electrolyzer to their large-scale Hornsey wind farm. And in fact, if I get a call from a number I don't recognize, pretty much once a week, that call will be from some new renewable developer who I've never met, who is essentially have renewable projects which are ready to go. Either they can't secure grid capacity to connect their renewable development to the grid, or they don't trust the electricity market to give them the prices that they need to get their project away. And of course, hydrogen can fix those. It can provide an alternative route for their renewable energy and can provide a completely different market, which it looks like they can use to create a case for hydrogen. So for their fundamental renewable energy deployment. So I guess what we're seeing is a physical manifestation, a real market manifestation of something which hydrogen proponents have discussed for a long time, which is that hydrogen provides the interlinking role within the overall energy system, and that it's actually very hard to get to net zero carbon in a world where we're relying on large quantities of renewable energy without some form of interlinking fuel. And that's something that the Committee on Climate Change has very much recognized in their recent reports. And of course, the other option is the fossil hydrogen. This is something which is only going to happen at large scale. And in fact, we see the UK's large industrial clusters all looking like they're going to be developing large scale CCS based hydrogen production, really for industry in the period 2025 to 2030. So we'll have decent quantities of very low cost and low carbon hydrogen available in that period. But all of this starts to throw up quite interesting challenges when this sort of desire for a policy push to help make hydrogen happen butts up against the LCA community and some of the rules that we heard Chris talking about. I guess you see that in two ways. The first is just the macro point. On the previous slide, earlier we saw a graph of very high carbon intensity being talked about as kind of the incumbent way that hydrogen is generated, and that it doesn't square with the fact that pretty much any new plant for the transport sector would be developed in an ultra low carbon way. So there's a kind of a macro point, but then there's a second point, and again Chris referenced it, which is when you get into the fiddly details of these policies, in particular the RTFO, the implementation of RED II, then the details of the sort of LCA thinking in the policy making can cause quite serious problems for the development of this new technology. And there's no better way to see that than this notion of additionality with respect to the electricity you generate, you need to use. Again, Chris referenced it. if the purest argument is that if you put electricity into an electrolyzer that isn't additional, isn't in some way enhancing the amount of renewable primary energy that goes into the energy system, you're robbing it from somewhere else, and therefore you're not necessarily contributing to the overall CO2. And so we now have rules on what constitutes additional electricity. You can either directly couple your electrolyzer to a wind farm and not touch the grid. You can use constrained power that would otherwise have had to turn off because the grid couldn't take it. Or you can do so-called new renewables, which is basically renewables built after the electrolyzer. And this is kind of fine from a purist perspective, and I fully understand where it comes from. But what you end up with in the real world is developers tying themselves in knots trying to get these first hydrogen projects away, which we can concede is useful for the energy system of the future, having to synchronize the development of the renewables with the development of a wind farm. And these are both 3 to 5 year lead time projects. And you end up in painful knots, which very much risk delaying the start of the sector. And when you take a step back and you look at the energy system that you're creating, whether or not the wind farm was built before or after the electrolyzer doesn't much matter. At the end of it, you have a wind farm and an electrolyzer providing the energy system benefits that we expect. So I think there's a sort of a plea from the renewable hydrogen sector for a degree of flexibility on this, particularly in the short term while we're trying to get moving, with an expectation that eventually you can move to the purest interpretation. The second issue is around whether or not you can move energy via the grid. That's something which would massively increase the flexibility of these systems. Luckily, it looks like the UK government and the European Union are now going to allow the grid to be used to transport renewable electricity, provided it's additional and you have very firm guarantees of origin in place. So that's a movement that looks to be happening. On the blue hydrogen side, it's a bit like the biofuels. There are challenges in the upstream, essentially. And we're going to need to be very careful about upstream methane leakage and also capture rates. But I think the good news there is that this concern over how much carbon can be captured from a CCS plant is triggering really interesting developments in reformer technology that takes fossil fuels and turns it into hydrogen, to the point that we now see 98% capture rate as feasible in some of these blue hydrogen plants. So hopefully I've managed to give you a bit of a whistle-stop tour of kind of the status of the sector. I hope I've left you with a sense that hydrogen is now emerging as a serious prospect which needs to be taken seriously. And I think that second bullet for me is the key, that any hydrogen success in the transport sector leads to new plant. And in the current carbon world, there's no chance anyone's going to be building anything but a ultra low carbon plant. And also that it's likely that these new plants are actually going to stimulate primary energy, possibly more primary energy than they use themselves, by helping facilitate either renewables development or CCS. So I think there's an urgent need for a refresh of the kind of norms and expectations around hydrogen energy, particularly within some policymaking circles around its ability to behave as a low carbon fuel. And then more generally, we're looking forward to working with the low CVP and this broader community. I think we've recognized the need to provide a lot of evidence and proof of all of this from the hydrogen sector, and then get hydrogen kind of included within the LCA analysis in a way that's appropriate to its role in the energy system and also these future developments. So many thanks.
Thank you very much, Ben, for that whistle-stop tour, but very detailed at the same time. Right, now I'd like to invite all our panelists back, please. We've had quite a lot of questions from the audience. And I'd like to begin with a question for Penny, actually. And the question is, why is it felt that long range will not work for electric vehicles? OEMs are working towards increasing range. So Penny, maybe you'd like to answer that in the context of the roadmaps as well.
Yeah, sure. So I think you're right that, the long range may work for, if we're talking about passenger car, the ranges, if you look at ranges of the vehicles that are on the market right now, they look really quite practical. So, you're looking at 200 miles in not a very expensive car like a Tesla. So I think, in fact, what's happening is that the ranges in passenger cars are increasing, and these workshops were held last year, and I think possibly the discussion has moved on in terms of passenger car. So it may be at those battery electric vehicles, coupled with a really good charging network, because that's really important in terms of how usable those vehicles are, that will be a good solution. I mean, hydrogen maybe, just thinking about what Ben's been talking about, but what seems to be going on at the moment is the battery electric vehicles do seem to be becoming quickly much more practical. So I would say that the roadmaps are based on some work that we did last year, and my belief is that things have come on since then. Was the question about passenger car or other sectors as well?
It wasn't identified.
Right.
Maybe you can just sort of touch on the challenges, as you saw, I think, with the energy requirements for sort of long haul. It's a different picture.
Yeah, I think when I've started to do my sort of back of fag packet calculations, once you start looking at trucks, you're looking at tons of battery, and in that sort of trade offers to have a battery electric vehicle, you're increasing your vehicle mass, your payload, so you may be then having extra journeys, so your carbon reductions may be lower than you might have thought. I think trucks lie in a grey area, which, you know, it's difficult to say which way that will go. But when you start to look at ships, the batteries start to get really very large, and so I think in the longer term it will be impractical.
Thanks, Penny. A question for Carly now, maybe a little bit of a one on the spot. Do DfT have any policy preferences between the sustainable biofuels or sustainable electric? And what is the long-term goal for green ICE or EVs?
So I'm going to admit to being not familiar with specific policies in the electric vehicle things, because I think there's a lot of challenges there in terms of the infrastructure, the uptake, and all sorts of things. So from the sort of, I know that they've got the Road to Zero strategy, which has got set goals for electrification of vehicles, and there's the goal that there's not going to be any new conventional vehicles being sold after, I think it was 2035, I think, or 2040. So that's obviously kind of the setting the tone for the direction. In terms of the renewables part of the grid, I think that's another sort of whole bit of what BEIS is kind of overseeing, which is the grid decarbonisation, which is another sort of aspect. So so it's kind of like a huge question, because there's lots of different bits involved. So we know that there will be renewable fuels demand in just conventional roads for some time with the existing fleet and also in freight. So we're just one part of the pie, if you like, in terms of trying to fix everything. Hope that answers the question.
Thank you very much, Carly. I've got another question now that I'm going to raise from David Starley. It's with regards to hydrogen. So maybe Ben, you'd like to answer this. David says that currently, as far as he knows, the technology doesn't exist to effectively store hydrogen at large scale. There's a lot of research into storage mechanisms, but the statistics shown and expect for 2050, it seems to suggest that the storage issue won't be solved until very much in the future. So do you have a view on hydrogen in terms of large-scale storage?
I mean, clearly it's a developing area, but I think I would take issue with the idea that the technologies don't exist for large-scale storage. We already see hydrogen stored in large salt caverns in a number of industrial locations around the world, and in fact, when you start doing the system modeling, it's one of the very lowest cost ways of storing very large quantities of energy for a long period of time in salt caverns. So I'm not exactly sure. I mean, storage, you need different types of storage at different bits on the supply chain. You need storage on the vehicle, you need storage in your distribution system, and you get some inherent storage as a result of being a fuel in a distribution system. And then sometimes in some versions of these energy systems, you need larger quantities of hydrogen storage. So I think I would take issue with the question of whether or not the technology exists. There probably is a fair question whether when stored on a vehicle or when stored in a distribution system, that's being done affordably currently. And there's no question that it would be excellent if we could develop cheaper hydrogen storage vessels and there's a lot of research going on in that area. But I think when people are making these decisions to move into hydrogen strategically, they're not relying on these future technologies. So they're not relying on, for example, the people are looking at storing hydrogen as ammonia or looking at storing hydrogen in a liquid organic hydride. They're not waiting for those technologies in order to justify these strategic decisions. In other words, they're being based on the technologies that are available to us today. So I may have missed the sort of specific thread of the question, but I don't think it's a showstopper question. There's no question that better storage and better research into storage would be an upside.
Thanks.
Thanks, Ben. Final question is going to be from Greg. Good morning, Greg. Greg Archer. You've obviously posed a number of questions in our Q&A box. So I don't know if you want to maybe pick one of those or direct them to a particular panelist.
I'll ask the question I posed last to Ben. And Ben, you make a really excellent point about the need for flexibility in project development and evolving areas. But once a regulatory system is put in place, it's very difficult to then tighten the requirements in the future, and industry resist it very strongly. So how do you balance the needs for flexibility in the approach to begin with and the demands for regulatory certainty in the longer term?
That is a brute of a question, Greg, I think. And I think if we knew the answer to that, the discussions that the hydrogen industry has been having with the low carbon fuels unit around the RTFO would have been a lot easier easier to hold. I mean, I guess my instinct would be to try to push that back to the regulators. I think there are a number of ideas that you could imagine. You could imagine, for example, a time-limited window where you allow an exemption for a few years, and then you're explicit about closing that at the point that you make the regulation. So you're explicit about the reason for the window, and you're explicit about it closing. I mean, this specific issue around additionality is actually only a temporary problem. It's not a problem that lasts into the 2030s. It's a problem about trying to get hydrogen projects away today. Because really what you'd like to do is go and connect to an existing wind farm and take all of the wind farm development risk and timescales, etc., out of your project development cycle so you can get started with hydrogen. So it's something that I think you could quantify the length of time that you would need that waiver for. And it would be a waiver, and it would be, I would completely accept that to the purist it might look ungainly, but it would be something that could actually massively help accelerate the sector. I think. So something like a time window described in advance, communicate the rationale for it communicated in advance and agreed with industry for that rationale would seem to be the kind of way that you might do this. And I think the challenge is failing to do that means that you end up with much more expensive projects that are working within the rules, and you end up paying more by the state. So there is a rationale for the regulators to try to introduce that flexibility. I hope I slightly answered your question. It's a difficult one, and I recognise that it's a challenge. Could
I react to that briefly?
Please.
I mean, I don't disagree with anything really that Ben and Greg has said, but to react to the last point, I think that the regulatory framework tries to sort of hit this goal, which is always very difficult, of setting an even playing field for different technologies. And I think it's broadly understood that for these new technologies, there is a call for, additional support as they are rolled out and the rest of it. But it is also important to recognize when we're talking about effectively, these things represent carbon prices for different decarbonisation technologies. And if the hydrogen industry is effectively asking to have the cost of renewable power development sort of taken into a different pot, then in some sense it's about asking for a higher value incentive for their part of the industry than is available to other decarbonisation technologies. And that's not necessarily wrong. You can make the case about the importance of these technologies in the long-term decarbonisation pathway. But I think it's a sort of a difficult needle for regulators to thread, balancing this need to move stuff forward with not writing a blank check for whichever technology sort of sounds most interesting at the time.
Yeah, I think that's kind of fair. I think that there are some specific challenges that are related to the hydrogen sector, which is really what it would be good to see happening in the hydrogen sector, is for it to move away from a world of capital subsidy and one-off demonstration projects and into this regulatory world. And I think partly because there's no specific other program for hydrogen, there's been a desire to get it into some of these regulatory worlds, perhaps quicker than some of the other technologies might do, and that's caused this challenge, and it's caused this request for flexibility. But just to answer the point on carbon pricing, I don't think this is actually a request for kind of higher incentives. It's simply a request for flexibility to allow one to get to the point where the existing incentives, and in fact lower levels than the current incentives, could enable kind of a fully purist acceptable LCA with respect to hydrogen. So I think there are some sort of specifics of the nature of the support that's available for hydrogen and the desire to get hydrogen into that regulatory landscape early that mean that that's why these discussions are taking place.
Thank you both. Interesting discussion. We're nearing midday now, and I'd like to thank all our panellists, Kylie, Ben, Chris, Penny, for your excellent presentations, and thank you very much for coming today as well.
So please feel free to sign up for our session tomorrow. So that's closing the loop, end of life. So really focusing on the recycling, reuse, repurposing, so all that side of it. Some great speakers are lined up for tomorrow. Thank you all for attending and taking part into the chat and in the questions. If we didn't answer your question, I'm sorry about that, but we'll try and get answers to you post the event. As I said previously, all the presentations will be available after the session. And please, would you take the time to fill out the survey when the session closes, because we really appreciate your feedback on how we performed. Stay safe, stay well, and hopefully see some of you tomorrow. And thanks again to all the panelists. Thank you.